Right, in this video clip, we're actually going to take our measurements so that you can calculate density. To start with, here's the objects I'm going to measure. I've got two different pieces of wood. They were cut from the same board, but two different sizes. Got two different sizes of copper, two different sizes of cork, and I'm going to measure out two different amounts of water. Let's get started. To start with, I have to find mass of the object. So here's the balance, and we talked about the fact that this measures mass and it measures it in gram units. So I'll get this turned on. It doesn't read exactly 0, so I've got a button on here I can push, a 0 button. Right, now it reads 0. I'll put that on there, and that happens to have a mass of 71.86 grams. I'm going to put that right there. Next, I have to take the volume. Now remember, we have three methods to do that. Since this happens to be a regular shape, I'm going to take length times height times width. So here's that first number. The length is 15.2 centimeters, and I'm going to put that right here. The height on this is 1.9, and the width on this is 5.5. Right, now you have length, height, and width. You'll have to calculate volume. So don't forget to do that. Take length times height times width. And don't forget that those units are going to be cubic centimeters, because we take centimeters times centimeters times centimeter. So that's the first block. Second block, I'll mass it. And that comes out to 135.31 grams. And just like the other block, I'll take length, height, and width. Now this time, length and height are close. It doesn't matter what I call length, what I call width, just so I have all three dimensions. So I'll just take this as the length, and that is 13.1 centimeters. The height right here, since they were both from the same piece of wood, that height is the same, 1.9. And the width is 11.2. So once again, you'll have to get the volume to put in right here by taking length times height times width. And don't forget, those units are centimeters cubed, because we have three dimensions, length, height, and width. All right, that takes care of the wood. Next, we've got the copper. I'm just going to say this is the small copper. I want to be sure to weigh this first before doing the volume. See if you can figure it out. I'm going to put that on. And it has a mass of 58.11 grams. Since this is not a regular shape like the block of wood, I have to use a different method to get that volume. So I'm going to take water displacement. To start with, it doesn't matter how far I fill this up, just so long as it covers that piece. So this starts out at, this is at 50.0 milliliters. I'm going to put that right here. I'm going to tilt it so I can gently slide this in so I don't break it. And that now reads 56.5 milliliters. So again, here's your information. You'll have to calculate the volume. Since that cylinder is in units of milliliters, I'm going to put that right there. So I started with that cylinder at 50. And after I put that object in, it went up to 56.5. So that difference of 6.5 would be that volume. Okay, second piece of copper. Get that dumped out. Second piece of copper, and think again, why do I want to take the mass before volume? That piece of copper is 79.36 grams. And I'll take that cylinder and I have to always read this at eye level at the bottom of the meniscus, that curve. And I've got 38.0 milliliters, which is plenty because this isn't as tall, so that should cover it. Tilt it so it doesn't break. Right, and this goes up to 47.0 milliliters. So once again, use those numbers to get that volume. All right, our third set of objects, we have the corks. So to start with, I'll get the mass. That small cork is only 2.82 grams. All right, look at that cork though. Doesn't have a regular shape, so I can't take length times height times width. And if I put it in here, it could get stuck. So I'm going to use water displacement this way. Now get this spill can filled up right to this part right here where the water starts to actually drip out. And they call it a spill can because that's what happens when I put this cork in or any other object. Empty this. Since that cork floats, I actually have to push it under the surface of the water. As it moves into that water, it pushes or spills that water out. The amount of space that that cork takes up is the amount of water that it pushes out. So that amount, if I read that at eye level, the amount of that cork is 5 milliliters. That's what it pushed out. So I'll put that right there. Yikes. Right, the second cork, put that on a balance. That cork comes to 15.35. Once again, I'm going to get this filled up right to the top, right to that opening. And I'm going to empty this. Get it right there to catch that water. Put the cork in and push it down so it's completely underwater. Collect that water that it pushes out. And read this at eye level at the bottom of the meniscus. And that volume it pushed out is 27.5 milliliters. All right, our last samples. So I'm going to take my graduated cylinder, put that on the balance. Now, obviously, it weighs something, but I don't want to include the weight. I'll put that on the balance and hit that 0 button. That 0 button cancels out the mass of that object. So now it reads 0. So I'm going to add, I use this so I can get exactly 10 milliliters into that graduated cylinder. Right. So I have 10 milliliters and it reads 10.11 grams. Right, this time volume is easy. Whoa. This time volume is easy. This is a direct measure. And I've got 10 milliliters. And I'll be lucky to get through this, won't I, without breaking something. Second sample, put that back on again, 0 it out. And I have to have 25 milliliters. So I'll put some in. Take this to finish it so I get exactly 25. All right. This time my balance reads 24.97 grams, and I'm going to let you figure out that volume. So that's our measurements. What you have to do is fill in the volume spaces and calculate the densities. Be sure to have correct units. As we talked about in the other